Okay, so we went over all these rules in details, and we did plenty of examples. So basically what we're going to do today is do more examples of this with more variables. So it's not always one variable times one or one variable divided by one. Could be multiple variables times multiple variables. Could be numbers also, in addition to that, numbers here, and also here. It could be numbers here in the fraction and so on. So I'm going to do many examples basically of these rules and see how to apply them. So this is basically part 2. So going to be simplifying expressions. All right, so first example, something like this. So xy, for example, multiply some other expression xy, and we have some powers here like 3, 2, and maybe 4 here over the x. All right, so it's a multiplication, so that means we're going to be using the first rule. We have two variables here and 2, so we're going to multiply the x's together, so x3 by x4 together, multiply the other variables y2. And what's the power of this y? It doesn't have a power, that means it's power
1.
That's right, it'll be power 1. That's it. Now that we put those two together, what do we do with the powers here when you multiply according to the first rule? So x4 times or x3 times x4 will be
Plus
x, that's right, x to 7. And here for the y's, it will be y2.
3.
That's right, y to the 3rd power. And that's it. We just multiplied these. Again, this applies. Doesn't matter how many variables you're multiplying. If the bases are the same, you add the powers. Bases are the same, you add the powers. And like I said, you may even have numbers. You may even have numbers with the variables. For example, -5 times xy. Let me just write that down here. So you may have something like this, for example, 5xy, and this multiply another term like this, maybe 3xy. There could be even some variables here, for example, -2, maybe 5 here. And also maybe 4 and 3. Okay, so it's the same idea here. We're going to multiply these two. So first we need to multiply the numbers. These are just regular numbers, not powers. So we're just going to multiply them. So -5 times 3. Then we need to multiply the x's together and also the y's together, just like we did in the previous example. So this would be x -2, x5, and the y's together. We have y4 times y3. That's it. So we times the numbers together, and then we times the similar variables together. And so this would be -15. What would this be equal to? X to the power -2 times x5.
3.
That's right, it will be x to the power 3. So we're combining these two. And also here, we combine those two. So it will be y to the power 7. Okay, so we're just adding the powers basically, just like the rule 1 or the previous example. So that's how simple it is if you're multiplying two terms like these. This is not a distribution, by the way. It's just one term times one term. It's not like this, the distributive property we learned last time. It's not like going like this and then multiplying again. This is not what we're doing here. It's just one thing times one thing. So times the numbers together and the similar variables together. It's not a distribution because you don't have addition here or subtraction in either of the parentheses. There's no additional subtraction between variables or numbers, so it's not a distributive property. So this is basically just one multiplication, invisible multiplication here. Or it could be 1 times 2 of these. 2 of these in parentheses. In that case, it would be distribution. For example, if you have, let's say 2xy times 2 terms inside, maybe 5xy minus some other term, 6y, and some different powers. Let's say 3, 4, and 2, and maybe -1 and 5. So now this looks like a distribution. So we're going to have to multiply this and then multiply again. So this will be a distributive property. Unlike here, it was just 1 times 1. Here it's 1 times 2. So we're going to have to distribute just like we did. So basically, it's going to result in 2 of these. 2 multiplications like this, 1 and 2. So let's write down the 2 multiplications first.
10.
Okay, let's maybe write them down first and then multiply. Let's just write them next to each other. This times this, so it will be times 5x4 y2 minus this times this. So let's times this again, 2 times 6. I mean, before that, let me just write the whole thing, 2x to the power 3. So this multiply the other term, we just bring this term next to it, time 6xy. Okay, as you can see, we have 2 multiplications. We have this multiplication and this. So 2 of these. We have 2 of these multiplications here because we had 1 times 2 terms. So we distributed. Now let's go ahead and multiply just like we did. So what is this times this, the whole thing?
Professor, 6x and minus 1.
Minus 1. That's right. This is a minus. So hidden here. So we have a minus.
Will be 10x7 y3.
Okay, let's see. That's right. So 2 times 5, that's 10. Then we have x3 times x4, that's x7. Then we have y1 times y2. So the invisible one here, y1 times y2 is y3. And same thing for this second multiplications. What do you get here, everybody?
Minus 12x2.
Okay.
Y.
That's 12. That's right. x3 times x -1. Combine them would be x2. And finally, y1 times y5 would be y6. We have, since we multiplied, we had 2 multiplications, so we result in 2 terms. And these can't be simplified unless they both have the exact variables and the exact powers. For example, if this also had 7 and 3 here, then we would be able to combine them by adding or subtracting these, just like we did before with the like terms. But these are not like terms. Okay, these are not like terms because, again, you need to have the exact variables to the exact powers, but the powers here are different, so we can't combine. And that could be even a third term here. It could be 2 terms and a third one. Same thing, we do another multiplication or even more. So take this, distribute it over the inside of the parentheses as many times as needed. And then pretty much you get a bunch of these. Multiply the numbers first if you have them, multiply the similar variables and add the powers. So that's basically, these are applications of the first rule here. Okay, everybody, any questions about this part? Everyone?
Nope.
Okay, everybody else, are you okay with the rules? So as I mentioned in the previous class, This is really, really important in this class. This whole algebra class will be based on things like these. So it's very important to understand these rules and know how to use them. Okay, now we're going to be using them pretty much with every other topic. We're going to be using them with equations, factoring, functions, polynomials. Everything basically will involve powers and variables. That's why it's called algebra. Algebra is when we use letters to refer to numbers. So again, these are very important, and understanding these and understanding how to use them when to add, subtract, or multiply would make the previous topics a lot easier to understand because of this. So now let's move on to see something like this, not just with one variable like here, but maybe with multiple variables, maybe even some numbers. So let's see how to do that. So for example, some x and y, a couple of powers here, maybe 6, 2, and maybe 3 and 8. 8. Okay, so according to the rule here, number 2, how do you simplify these? What do we do with the powers?
Minus 6.
Subtract the powers minus the powers, correct. So for example, x6 over x2, it's going to be x6 minus 2. The a minus b, whatever a is. So a minus b in this order, not the other way around. The top minus the bottom. Same thing with the y, which is going to be 3, take away 8.
So, and in the next step, x and y will multiply, right?
Yes, so it's already a multiplication here.
Mm-hmm.
So we just, so when you subtract like this, when you no longer have a fraction, it's a multiplication here, but you can think of an invisible one here in the fraction. So now we just need to subtract the powers. So it would be 4 and y to the power -5 over 1. Are we done here, or do we need to do something else? For this answer, is there anything else we need to do here?
Yes,
You're done.
to make the y positive, put it in down.
Exactly. So we never even you end up with a negative power in a fraction. Just move it to the other side, and the power will turn positive. So this would be x4 over y5. And that's it. So the final answer should only contain positive powers. If the negative power is here, you move it up. If it's up, you move it down. You only move the negative power, not the positive. This is fine, it stays here. This is a negative power, we moved it down. So now that's our final answer. So that looks better than this. Looks simpler. That's why we say simplifying. So it looks simpler than this expression. And all the powers are positive, so that's good. The next example, sometimes you may have numbers here, regular numbers, fraction. So you could have, for example, 15 over 45 or 35, and a couple of variables or more, it doesn't matter. The rule is the same. And you could have, for example, -2 here. Or maybe, let's see, maybe here, -1, for example, and 5. And possibly 3. Okay, same thing. Let's see how to simplify this fraction. We're using mostly rule number 2 here. So what exactly do we need to do here first? Or what can we do in general on this expression to simplify it as much as possible?
Professor, can we divide it?
Can we divide? Yes, what do we divide?
For example, 15 over 35, x on power -1 over.
That's right. So first, we would start with the fraction. You want to reduce it. Divide or reduce. So what do we reduce this by? The 15 and 35. We can reduce by. In other words, what goes into 15 and 35 that we can cancel?
5.
The 5. That's right.
3 and
5.
7.
3 over 7.
That's right, because 15 is 5 times 3, and 35 is 5 times 7. These two will cancel out. The 5s will cancel out. This will stay, the 3 over 5. And then, like I said, whenever you have negative powers, try to make them positive. So maybe not here, because here it was easy. When you combine them, the negative power goes away. Negative 205 turns into 3. But when you have fractions, before you start subtracting, it's always a good idea to move the negative powers to the other side to make them positive. So if you see any negative powers in a fraction, first make them positive. It makes it easier afterwards to add or subtract. If you don't do it now, you'll have to do it anyway. For example, if you do -1, -3, it will be -4, and you still have to move it. And subtracting the negatives can be confusing sometimes. So reduce the fractions and move any negative powers to the other side. So this is negative, it's going to move down here next to x3. And here we have y5. The power of y here again is invisible, it's power 1. No need to move anything here, I'm just going to subtract just like we did previously. So this subtract just like the rule says. So we're going to do y5, take away 1. So again, we're going to reduce fraction. We moved this down, it turned positive. These we subtracted, there's no negative, so we subtracted right away because they're in a fraction. So the 5s cancel out, so we're going to have 3 over 7. And y5 minus 1, of course, is y4. And here now, what is x1 times x3?
Professor, why we couldn't
x1 plus 3.
and make
Which is
x1 plus 3.
X4.
x4. That's
Professor,
right.
why couldn't do x like -1, -3?
You could do that. You could do it too. It's going to be -4, and then you'll move it down. It becomes this. Right? You can do it. It's not a problem. But I think it's convenient to make all the powers positive first. It appears simpler and less confusing. Okay, so whenever you see negative powers, first move them. Move the negative powers, either from here to the top or top to the bottom. Once you have all positive powers, so this is easier to just add instead of doing -1 -3, which is a -4, and you still have to move it down anyway to make it positive. Okay, so that's the final answer here. There's nothing else we can do here. The bases are different. As you can see, the bases are different here. So we can't add or subtract these. And that's it. So at least you went from this expression that looked a little complex with the bigger numbers, but now this is much simpler. And that's it. That's all you can do to this example. Okay, everybody, understand these couple of problems here? Any questions, everyone, before we move on to another one?
No.
All right. So let's see. Let's do another problem here. So let's say we have, again, a couple of variables. This time we're going to add some parentheses and another power outside. Let's say we have maybe -1 and 4, maybe -2 here and 3. I need to raise the whole thing. So the whole thing, we're going to raise it to another power, maybe to power 7. So whenever you see something like this with parentheses, an expression inside the parentheses and the power outside, we do this in the order of operations. We do this in the order of operations, which means, what do we do first? Where do we start from according to the order of operations, if you want to simplify this?
You multiply the powers
Parentheses.
power 7.
Now, before that, we need to do the
bracket,
parentheses. The parentheses. So the parentheses, and then what is the E for?
Exponent.
The exponent. Very good. So when you do this, do it also in the order of operations. So start with the parentheses, meaning just work inside, ignore the power. Work inside completely, just like we did here. Once you're done inside, you work with the power. We'll see how to do with the power later. So do not multiply this 7 times. Do not multiply this by itself 7 times. That's redundant, long work, but we would rather work inside first. Exponents, and of course the M is for multiplication, D for division, addition, and subtraction. This is the order in which you do operations. If you have multiple operations together, always start from the parentheses first if you have them, then you go to the exponent. So I'm going to do this first before we do the exponent. Okay, so let's focus inside now. So what do we need to do inside here, inside the parentheses? What happens inside the parentheses?
Take the negative first.
Okay, move the negative. So this moves up to make it positive.
Minus 1, and we can switch or
Mhm.
move y negative y on
That's right. You can also move this one down here. You can still do the subtraction right away if you want, but again, it can be confusing. So it's going to be 4 minus -1. This would be -2 minus 3, which was still going to be negative, and you have to move it. But it's probably convenient to just move the negatives first. So this moves up, becomes x1 times x4. This moves down. The y3 stays here. The y -2 becomes y2. So now it's easier to deal with these. What's x1 again times x4?
X5.
x5, that's right. And then you have y3 times y2,
Y-
which is
Y.
y5. That's good. So inside parentheses first. Inside the parentheses. That's what we did. And once we're done with parentheses, we're going to see what to do with the exponent. So basically what this means is the 7th power here belongs to the entire fraction. As we saw before when we first talked about the exponents, we can split this. We can split this instead of writing the entire fraction to the 7th power. We could write this by itself to the 7th power. So x to the 5th to the 7th over y to the 5th also to the 7th. Okay, so now that we wrote it this way, how do we simplify this again? And which rule do we use from the list?
45.
Rule number 3.
So x,
45.
not 45. So what do we do with the powers? According to rule number 3, we have to.
Right? We have
No, before that, before we minus, we need to simplify this first.
Yeah.
Multiply. Multiply. Yeah.
5 multiplied by
Multiply.
7.
Yeah.
That's right. So we multiply the powers according to the rule number 3. Multiply A and B.
Doesn't show
35.
That's right. 35. And here,
Y
Also-
35.
also 35. So they happen to be the same. They happen to be the same power. We can put them actually together now because they happen to be the same power. If you remember this rule here, which one was it? This one. If two bases have the same power, two different bases have the same power, we may combine them together in parentheses to the same power. We could have done that here actually, could have done it here after simplifying, but again, just trying to show you all the steps with all the rules. So now we can put these two back together. This rarely happens. It rarely happens that you end up with the same power here, but if you do, you may write them together in one power like this. but this would still be fine. But this is unnecessary. It doesn't always happen that you end up with the same power here. But if you do, you can combine the bases together to the same power. But again, this is still good. So that's what you do when you have a power over the parentheses. So that power basically belongs to everything that's inside the parentheses. Because as we talked about before, the parentheses determine the base. So this whole thing is the base and the power is 7. So 7, basically we distribute it. It belongs to everything inside the parentheses. Okay, so that's what you do when you have power over. Yes?
Could you please sign the word chronosis?
What is it?
Chronosis. How could you write the word, please?
Write it?
Right. Write
Okay.
down the word chronosis. How do
Parentheses. Parentheses. Okay?
what's the first letter?
P. Parentheses. You know,
Um,
parentheses, these, the symbol.
Thank you.
Okay. Let's do another one. This time, let's see what happens if this power is negative. We're going to do something like this, basically. Let's see what happens if you have a negative power instead of a positive power. So let's take another fraction. So maybe let's mix things up a little bit. Maybe something like this. 28, couple of variables. And again, some powers. Maybe another power here. And the whole thing, we're going to raise it to some power, maybe a negative power. Okay, so this is basically as complex as you can get, as you can see. This is the most complex example you will ever see when it comes to these. Because it has a bunch of things going on inside, some negative power and a negative power over the entire fraction. So watch closely here. It's not really that difficult. It will take a few steps, but it's not really that difficult. We have all the rules. We just need to, we have the rules, we have the steps. We just have to do them carefully. So we may have to use most of these here. For the first problem, for the previous problem here, it looks like we used this rule, this, that one, and also this one. We used 5 of them just to simplify one example. So when you have fractions, you usually use multiple steps and multiple rules. With multiplication, it's basically just one rule. For multiplication, we only use the first rule, pretty simple. But with fractions, we involve a bunch of these. So let's see how to simplify this one. So first, before you think about the details and everything, there's only 2 main steps here. There's only 2 main steps to simplify this. And then those 2 main steps have some lot of details. What are the 2 main steps here to simplify this? Just generally speaking, not the details. What do we do first?
Inside the parentheses, simplify.
That's right.
Only thing inside the parentheses, then
Mhm.
apply negative 5 power to all sentences inside.
That's right. So that's how you should break it down. So there are 2 main steps inside the parentheses first. Again, just like PEM does. So inside the parentheses first. Number 2, the power or the exponent. We'll see how to deal with that exponent when we get to it. That's basically the breakdown. So at least you know your 2 main steps. And each one of these involves a few details. So when you go inside the parentheses, you will know what to do, will be obvious what to do inside. So what is exactly that we do inside the parentheses now?
Move the negative
We
down.
can simplify 21, 28, so we can use number 7.
That's right. Both of those steps we need to do. So the power now, just ignore it, leave it there. We'll do it later after we finish the parentheses. So inside the parentheses, okay, so we need to reduce this. What goes into 21 and 28?
4 multiply 3. Oh, no, I'm sorry. 7 multiply
3,
3.
Okay. And
7, 4.
4.
that's right, 7 times 4. So that means 7 is common. We will cancel it later. Then we have x6 over x2. What do we do with the powers here?
Combine.
Combine it.
X6 over x2. Exactly what do we do? What's the operation?
Don't you keep it?
6 plus 2.
Are you gonna divide?
Not plus, not divide. But again, look at the rule number 2. When you have a fraction and you have base,
You're gonna subtract them.
Roll.
subtract. That's right. We're going to subtract these. Then what do we need to do with these? Or what's the first thing we do here?
Move it to the base.
That's right. So move any negative power first. We can do all these at the same time. So the y7 stays here, it's positive. The y negative 1 moves down, becomes y1. That's what you need to do inside the parentheses. Obvious steps, obvious things, but again, remember the main thing to start here before you do the negative power. All right, so let's take care of that. 7 and 7 cancel out. You're going to have 3 over 4. It's very important to reduce this. If we don't reduce it, and later you raise it to the 5th power, it's going to be a big, big number. It is very, very important. Otherwise, you're going to end up with tens of thousands here or millions. That's why we reduce it first. That way, afterwards, when you raise it to the power, it won't be that big. And this is x4. And of course, y7 times y1 would be
7.
no, y7 times y1. What do we do with the powers again?
Combine it.
You combine.
Okay, so what do we get?
8, y8.
8. So we add. So here we add. When you times, you add. But if you have division or a fraction, you subtract the powers. So this is rule number 1. This is rule number 3. Good. Looks like we're done with the parentheses. Completely done with the parentheses. Now, let's see what to do with this power. It looks like a negative power. I believe we learned last time how to make it positive. How do we make this power positive? And which rule do we use from here?
Switch up and down side.
Okay, which rule is that from this list?
5.
That's right. When you have a negative power over an entire fraction, you flip it upside down. X over y becomes y over x, and the power turns positive. Power turns positive. So we're going to flip this, so it's going to be 4 x y to the power 8 over 3 x to the power 4. The whole thing, again, instead of negative, it's going to be positive power. That's important. If it's negative, flip it. If it's positive, no need to flip it. If it's positive, just go ahead and distribute it. Distribute it. So now that we have the parentheses simplified, we have a positive power. We just need to distribute this power over the parentheses. Every number or letter here gets this power because 5 belongs to the entire thing. This is the base. So let's first break it down, meaning we're going to write each one of these to the power 5. So 4 to the power 5. Then y to the 8th to the power 5. Then we're going to put 3 to the power 5. X to the power 4 also to the power 5. Okay, we just again distribute that power to everything inside the parentheses. Then you try to simplify these. What is 4 to the 5th? 20 times 20 times 5. 20 times 20, 4,000 times 5 is what? 20,000 or something like that. Let's see. So 4 to the power 5 So again, it's 16 times 16 times 5. That's not too big. Okay, so again, if the number here, if the value of this has less than, if it has 3 digits or less, you may write it here. If it's too big, if it's more than 3 digits long, it's okay to leave it like that. So again, if we expand for, so it's going to be 16 times 16 times 4, which is 1024. 1024. So you may write it, but it's okay if it's more, again, more than 3 digits. If it's in the thousands, just leave it like that. We're trying to make things simple, not complex. This one might not be, it's going to be, I believe it's going to be less than 1,000, less than 3 digits. So 9 times 9, 9 times 9 times 3, I believe it's going to be 283 or something, 283, if I'm right. So 9 times 9 times 3, 243, that's right. Okay, so this one, as you can see, is 3 digits long. That's fine, we can write it down. This one is over 3 digits, it's 1,000 and something. What about this? Y to the 8th to the 5th would be?
Y to the 40.
To the power?
To the 40.
40th power, that's right. The y to the power 40. And here, x to the 4th to the 5th would be?
Really?
20. Again, just times these. For these, again, we simplify them. Again, imagine if you were doing 21 or 28 to the 5th power, that would be like trillions or something. Let me see. So if you do, for example, if you didn't simplify this and you try to do, for example, 28 to the power, let's say 5, it is 17 million plus, 17 million plus instead of 1,000 here or 243. So that's, again, the reason why we simplify it first before we apply the power, because the power amplifies things. It makes everything much, much bigger. It grows exponentially. That's why you want to simplify the things first before you give them the power. Okay, so again, this is as complex as you can get. Remember, when you see this, it doesn't have to be complex, doesn't have to be confusing, or no need to panic. Just remember to do the 2 main steps, this and then this. And when you're inside here, you can clearly see what needs to be done. Simplify, move the power, subtract or add. Once you're done with parentheses, if the power is negative, flip it. If it's not negative, it's positive, just go ahead and apply it directly to what's inside of it. So that's your, that's basically how you simplify your expressions. Could be like one thing here, one step, one rule, or you may involve a bunch of rules and a few steps like this. And this took, basically we used this, we used that rule, that one, this one, this one, and this one. So we used all the rules to simplify that specific example. Okay, so again, that's why these rules are useful, and they will be applied to almost every topic we will learn in this class. Again, make sure you know your rules and sure you review them regularly. We're going to be using them throughout the semester. Write this list somewhere or take a picture of it, put it on your phone or something. So make sure you review this. This is basically the backbone of this class. It's all going to be based on these variables and powers.
Professor, may I ask a question?
Sure.
About the homework? I saw that you have inserted the links on the Blackboard.
I did, yes.
Yeah, but when I click there, it shows me a platform to sign in.
That's right. So you need to sign in first.
To
And
sign,
just
not to sign up.
In class,
for the first time, For the first time, you have to sign up. You have to have an account with the ebook.
With my ASA email, right?
Believe so, whatever the information there. So the first time you sign up, you only have to do it once. Afterwards, once you signed up, just
Okay.
click the link and you will.
Course ID or program ID.
Grammarly does more than catch
Oh, I'm
errors.
sorry, was that?
With Grammarly, you can find really good, no, perfect words that make your writing.
What was that question again? I'm sorry.
It's asking enter course ID or program ID to register.
I shouldn't ask for that. I believe you should just open the link. Did anybody try the link? How did it work?
It's the option register to a course required by an instructor or
Mhm.
register to self-study access only.
Well, try that self-study.
Self-study,
And
They ask
should
for a
take-
code.
we will be able to share with you our homework.
you should be able to see it, yes. Did anybody try the links? How did it work?
Okay, it's do you have an access code? Is asking. Yes, I have.
Okay, let me see. Anybody else tried the link? And how did it work?
We
Anybody
have
else tried it?
access. Looks like we have.
Yeah, I just asked if somebody else worked it out.
No, teacher.
They
I
give
don't
like
see.
you have to buy the access code or you have access code.
That's
To
right.
buy-
So you sign up. Yeah, you may need to sign up for the thing. Okay, because the other classes, you just click the link and you open the homework for them. So make sure you signed up for the ebook first. Right, so the ebook, as I showed you on course resources, you have to sign up for the first time. The first time only, probably will ask your email or something. Afterwards, I believe you just click the link and it should open the homework.
No, I am already linked with my book, but they're saying that you have to give access code. Which access
Professor,
code
can
I
I
have to
share
give?
my screen?
Access code. I have to give you access code. You said.
Can I share my
Yes.
screen, Professor?
Okay, go ahead.
Have access code, credit card, or PayPal. So and we have to pay or have some access code.
Right. So yes, that's the should be with the whole package book, whatever. It's part of the ebook.
We don't have it.
So the whole package of the ebook. Once you sign up for it, I believe it comes with it.
We didn't see
I don't know if I have an access class. The access book. The access code is basically yes. So because let's see. Yeah, so if you get the ebook on Blackboard in course resources, as I showed you last time, that should give you access to all the resources of the ebook, including MyLab, I believe, and then multimedia and some other resources. Okay, just try it. I've seen other classes opening without a problem. So for the first time, you have to sign in this. And contact your financial aid office about the charge or the fees, whatever. I'm not sure about those. So talk to them and figure out how much to pay or how to pay or something like that. I'm not exactly sure about the finances of it.
We have to ask them how to register on Pearson platform.
Pearson is the publisher of the book, yes. So you gotta definitely have an account. Sign up first so you can have all your books in one place, just like Cengage. You guys have Cengage?
We can
For the other.
Cengage.
I don't know. I don't know if it's offered by Cengage, but for now we use the MacBook from Pearson. Cengage gives us other books, but all this again, I think you should ask your advisor to figure out how to get access to the book.
Because I can access to my book, but I cannot open the link.
I'm sorry, what is it?
I can access to my book, but I cannot open the link.
You can't open the what?
I can open the book, but the link you gave, the link like for the training, I cannot open it.
For the training. What about the
Yeah.
other links for the homework? Did you try opening any homework links?
Professor, I can open it, but how do we sign up? Because it requires a code.
Requires a code. So can you open the ebook? Do you see it?
Requires a code unless we have to pay it $65 for 6 months.
There could be a charge. I'm not really sure yet, but again, there is a package that includes the books and access to the
don't really
ebooks.
use this platform in other classes.
Yeah. So again, talk to your advisor or financial aid about these charges. There's going to be charged for sure. There's nothing is free, but how to pay for it and how financial aid is involved in it, I'm not really sure. So talk to your financial aid officer or advisor to figure it
So
out.
it is a requirement from the school to pay for this portal, for this kind of website?
I'm not sure. Okay, I'm not really sure. I know there's a package or something that for the books in your financial aid package, but I'm not really sure exactly who gets
Because
charged and how much.
in other
So
classes, we haven't used this kind of website. That's why I'm asking.
this is for math. So math is a lot different. So we're going to be using MyLab for this course. Okay, so from my I've seen from the other classes and students, they just click the link. Again, yes, you need to sign up somehow, pay or whatever. I'm not really sure, but once you do, you should have access to the homework. I can show
So the
you
homework
that.
is not on the ebook.
It's from that. When you click that link, it basically takes you to the ebook. That's part of the ebook, the ebook package. Okay, I will show you how it looks like when you click the homework here, for example. Let me see. Screen. So let me give you a few here. So x, y times x, y. Be 5, -2, 7 here. And something also like this. Okay, so maybe a distribution here, like so, for -1 and maybe 5 here over the y. And something with fractions also. And finally, another one like this. Okay, so the first 3 should take you just seconds, literally seconds, less than a minute. This one will involve a few steps, but again, pretty simple steps. All right, I'll give you 10 to 12 minutes to do this. Meanwhile, you can take a short break and stop your practice. And after that, we'll go over these problems. Go over these problems together before we call it a day. All right, so I'll see you in a few minutes, everybody. I'll be back. Everybody, are you done? Everyone, you done with the practice?
Yeah, the first one is 1829.
I meant 27. I meant to write 27, otherwise it would not be, it would not simplify.
We can simplify
That's the
it.
question.
Yeah. I meant to put it, I was thinking about the 9, that's why I put 9 there. Thinking about the common number 9.
Hmm.
All right, so as you're gonna see, these will take no time. This one will take a few steps. What is this one equal to? You put a 1 here, it will be
X on power 35. No, on power
Well,
12.
12. So we combine them, and y to the power
5.
Come on. Which is
Uh,
what?
-1, right?
-1.
Oh,
Okay.
negative 1. Sorry.
And then you can move it down. So it's gonna be x12 over y.
Y on power.
Okay. This one also. So I'm gonna distribute. Let's multiply this. What is this equal to? 6 times 3.
80
Power
X power 6
X power 6. All right. Now y3.
power
2.
That's
Y
right.
power
2.
2.
That's right. We multiply this 6 times 3 and so on. Minus. Then we're gonna do the same thing with the other one. So 6 times 2. That's 12. Okay. X2. Next one.
X3, Y8.
That's right. X3 and y8 here. That's all. Again, one step, and here maybe a couple steps. Next one, what's the first thing we do? Reduce by
by
reduce
9.
by 9. That's right.
But
9 into 18
6.
twice. 9 into 18 twice. 9 into 27
3.
3 times. So the fraction is reduced. Now we have x5 over x1, which is,
X4.
that's right. And we have y minus 3, y4. What do we do first?
It's gonna be Y7.
And that's right, y7.
Flip it, then combine.
That's right. So it's going
So
to
may
be,
I ask a question about this?
okay.
In this case, can we divide the main fraction into 3 parts, which is 18 over 27, x on 6 over x on first, and
You don't have to do that. It's just going to be split into 3. It's better to keep it together like this. You don't need to split into 2 3 fractions. You can do all at the same
I
time.
don't know if it is all right if we do that.
If you want to do it, just make sure your final answer is put together like this.
Okay.
To one fraction. Okay. So finally, this will be x over 4 and y7. Okay, so here that's it, 2 steps. Let's look at this one here. We have a fraction, parentheses, and the power. So again, where do we start from? Where do we start from?
We are flipping
Inside the
inside,
parentheses.
So before flipping, let's work inside. So x7 over x2 will be x5 over.
we have the same. We flipped it at the first side, so make the power positive.
You may start with that. You may do this, make it positive first, or you can simplify first. This you can do the parentheses first. The result should be the same.
Okay.
Okay, so this and what else?
Y3.
Y3. So it would be, that's right, it would be y minus 3 here, but let's put it down, will be 3. Okay, so now it's a negative power. We're done with parentheses. What do we do to make it positive again? To make it positive, we flip it. So it's going to be 8. So y3 over x5. Then just multiply the power. So it's going to be y to the third 3 times 8. be 24, and
Mhm.
x to the fifth to the x 4. That's right, just times it. 3 times 8, 24, 5 times 8, 4.
Mhm.
And that's it. So as you can see, only a few steps. I know I write all the details here, but you don't have to write each detail here. You may skip a few steps like we did here. 2 or 3 steps are fine. So it's not technically 1, 2, 3, 4, 5. I just try to write all the steps or all the rules, but as you can see, it can be done pretty quickly. And any questions about these problems, everybody?
No.
Everyone? Any questions? Everybody else? Let me know if you have any questions. And as always, you'll find this lecture on Blackboard.